Potential energy is a stored energy, and we had already talked about elastic potential energy, which is the energy stored in a stretched or compressed spring. Now we want to talk about gravitational potential energy, which is the energy stored due to an object's position either above or below a defined zero level. Now, don't be misconceived here that potential means that it doesn't have the energy. It has energy if it's above or below this zero height. The potential means is that it has the potential to do work. So the energy that it currently possesses has the potential to do work later on. So what we have to do first whenever we talk about gravitational potential energy is define where the zero height is. And we can call the zero height anywhere we want. Usually what we do is we call the zero height the lowest point. So if I call this my zero height, when I go and calculate my potential energy, I measure my height from that spot. Now, we don't have to call the zero height the lowest point. We could call the zero height the highest point if we want. And then our height would be our distance below that spot. So if we talk about where the person currently is, they would have a negative height. So we can have a positive height or a negative height depending on where we call zero. We just have to be consistent. And this means that potential energy itself is a very arbitrary number. If I look at this diagram of the buildings, if I have some kind of an object resting on one of the levels, if I call my zero height at this spot, then I would have positive potential energy. However, if I call my height zero at this spot, then I would have a negative potential energy. And if I call my zero height this spot, then I would have a zero potential energy. So it's a very arbitrary value, but what is not arbitrary is how much the potential energy changes. And that is actually going to become a more valuable idea. If I call this my zero height, and I talk about the potential energy, if this height is negative 5 joules, and this height is negative 10 joules, then if I talk about my change in potential energy from spot A to spot B, I would say that my potential energy went down by 5. My change in gravitational potential energy went down by 5 joules. Now, if I call my zero height down here, and then I talk about my potential energy, this would end up being 5 joules, a positive 5, and this would end up being a 0 joules. And so if I talk about my change in potential energy from A to B, my change in potential energy, again it went down by 5 joules. It's still negative 5. Even though I call my zero height somewhere else, if I were to call my zero height here, then this would be 0 joules at spot A, and this would be negative 5 joules at spot B. So again, my change in potential energy, it went down by 5 joules. So no matter where I call zero height, my change in potential energy is always going to be the same. And that's a more important idea than the potential energy itself. Just as work and elastic potential energy, gravitational potential energy is also a scalar. Our equation is that the gravitational potential energy is equal to the mass of the object in kilograms times the gravitational field strength, which is still 9.81 newtons per kilogram, times the height above or below that zero level. So again, if we're above the zero level, we have a positive potential energy. If we're below the zero level, we have a negative potential energy. And if we were at the zero level, that's the only time we'll have zero gravitational potential energy. So we want to talk about a problem here involving potential energy. It asks, what is the potential energy of a 0.25 kilogram baseball that is at a height of 20 meters in the air, and consider the zero height to be the ground. So here is our baseball. We are 20 meters in the air, and we are calling this to be our zero height. So we always want to label where our zero height is. We know the mass is 0.25 kilograms. We know our gravitational field strength is always 9.81 newtons per kilogram. And we know our height to be a positive 20 meters. We want to find the gravitational potential energy. So our equation, gravitational potential energy is mass times gravitational field times height. Our mass was 0.25 kilograms. We have our gravitational field is 9.81 newtons per kilogram, and our height is 20 meters. We solve for the gravitational potential energy, and we get 49.05. And this would be in joules, since we kept things in kilograms, meters, and of course newtons for our gravitational field.